Hi, I'm Cannon Lockburner, and I will be introducing the problem for the Colbot design project. So essentially our problem that we were given was to create a user-friendly remote control device that can power the that can control the Colbot and navigate it through a series of obstacles, and then pick up two I-beams one at a time and drop them in the back of the truck. And we met that design problem with this controller here. So essentially, to control the driving of the truck, we have two joysticks which each control one side of the tread. So the treads can go forward and backwards separately, forward at the same time, backwards at the same time. And then within the joysticks, there are two buttons, one of which when held will lift up the arm of the robot, one of which will drop the arm of the robot. And then finally, there are two buttons, one of which will close the claws on the end of the Colbot and one of which will open the claws. And the design is very effective because it's, pretty simply held in your hands. It's not too bulky. It's even got a lot of freedom of movement here, and it can complete the course in under 2 minutes. So it is pretty quick.
All right, I'm Jonathan Moore, and this is our wiring diagram. And if you look here, we have the two buttons that control the opening and closing of the claw, and then we have the two joysticks where we have our buttons are controlled by these pins, and then we use analog pins to control the forward and backwards movement of the tracks. And then for the receiver, we have the two servos that control the claw, and then we use transistors to control the power output to the DC motor to either move the motor forward or backwards. And then if you come down here, we have the two buttons. One of them, when pressed, closes the claw. The other, when pressed and held, opens the claw. And then on the joysticks, we have two buttons. One lifts the claw, the other closes, moves it down. And then these control the tracks. You can go forward on the right, backwards on the right, forwards on the left, backwards on the left.
All right, I'm Logan Kamrath. I'm going to talk through our team's controller design and how we picked these controlling interfaces that we did. Our design team went with two joysticks and two buttons, which the two joysticks allow for viable tread movement, and plug and play. You can just kind of move the joystick, which way the tread is moving. We went with the 4-button total design, 2 buttons for the claw, 2 buttons for the arm, so then we can have the most amount of separated motion of each of the individual components at the same time. And then we made a little bit of a housing that ideally on a job site, it would keep everything that is in here, it would keep it contained within this whole housing, and it would be small, so it wouldn't take up very much space, which is crucial on a very busy job site, as well as keep it weather protected, so then if it's raining and there's mud, snow, things like that, it wouldn't get in the way, and would allow a construction crew to actually keep their valuable electronics safe, while also being able to control anything that they would need to, like their Colbot. So we just kind of made this controller, and it fits everything very, very small, and it will eventually allow for 3D printed designs that will it will allow for rapid prototyping and rapid production of all of the controller housings, so that you can just kind of say, all right, I need another controller. We've got a new piece of equipment on site, so now we just stick it on the print bed and then set it to go. It'll be done in about 2 hours, and then you can just pick it up, not even after lunch. You could pick it up before lunch, get it working, and get your crews working. Very, very simple, very, very effective.
Hi, my name's Austin Whitman, and I'm here to describe the logic flowchart that our controller uses. First, we set up with the R4s, and then the controller and the receiver both connect. Once it connects, it begins the transmission, and this is when the the transmitter and the receiver start doing opposite actions. The transmitter side on the left here starts to read its 2 buttons and 2 joysticks. As the joystick goes up, it starts to read the value as higher and higher, or lower and lower if you move the joystick down. And it puts that in the data packet in the bottom. It does the same thing with the 2 buttons that control the arm. If button 1 is pressed, it sends that button has been pressed in the data packet. And it does the same thing with the claw buttons on the other side. And then the receiver gets that data packet, and then it decodes it so it knows how much the joystick has been moved, or if the buttons are pressed, and can adjust each of the arm angles and each of the track speeds individually. And then that occurs and moves the tracks and moves the servos to their position, and it repeats until you remove the power and turn the system off. And then looking at the code side, here's our data packet sending each of the readings from each of the joysticks, and the claw readings and the arm button readings. And then within our setup, we're setting up the servos, setting their initial values of safe limits so that when the code starts running, it doesn't try to overexert and go to something that it can't reach. We set up each of the pins, and this can easily be adjusted for different controller designs if you need more buttons, less buttons, control different stuff. Set up each of the input modes for each of those pins, and then we go get those readings from the controller and put them in the data packet. And then on the receiver side of the code, once we have that data packet, we set up each of the motors with their 2 transistor pins for the directional control. We set up all of the pins as outputs, and then we take those values from the joystick and convert them into intensities for the speed, either forward and back. And then if it's the positive on the left track, we go and set the correct directional values and output to the PWM pin so that it works. And then if it was the negative direction, we switch the directions and do the output to the PWM pin again. The same thing for motor 2 on the other track, but using the other joystick control. And then on this side, we have the arm and the claw reading. So if the arm up button is pressed, we go up by 5 degrees. And if the arm down button, we go down by 5 degrees. And these values can be adjusted depending on the accuracy that you want and the speed that you need. And we do the same thing with the claw. The claw increases by 5 degrees when you're closing, and decreases by 10 degrees as you're opening the claw. And we have these safe limits involved. So the arm angle cannot go above 150 or below 45 degrees. So then you don't hit those hard limits that are on the machine. And the claw stays between 90 and 5 degrees. And then we just set those claw and arm angles, make the machine go to those angles. And this repeats and repeats for every data packet sent from the controller.